Welcome to another day on the Journey Chez Chem. Well, today's warm-up question number 1 is both an empirical and a molecular formula problem. And number 2 is percent composition. Well, you do the best you can, and we'll see you in a moment. In number 1, the question asks for the molecular formula. In order to find the molecular formula, first I have to find the empirical formula. And I'm given a percentage, so I assume that I have 100 grams just like I have 100%. And 47.0 grams of carbon, and I have to change my grams to moles. I can only make comparisons in the mole format. And therefore I have 3.9233 moles of carbon. And 1 mole of hydrogen has a mass of 1.0 grams of hydrogen. And therefore, I have 6.59 moles of hydrogen. Now, in order to determine the amount of chlorine, I have to know what was the amount that I had of these materials. I will add them together, and that gives me 53.67. And then I know I had 100%. I take my 100 and I subtract the 53.67 to get my amount of chlorine. And I have 46.33 grams of chlorine. 46.33 grams of chlorine. And 1 mole of chlorine has a mass of 35.5 grams of chlorine. And therefore, I have 1.3050 moles of chlorine. In order to make a comparison between the atoms, we have to divide by the smallest. This is my smallest, and I am showing that I am dividing it by itself so that I see why this number is 1. And I divide it into the next number, and I see that comes out to be 5. And I divide it into my carbon, and I see that it comes out to be 3. Therefore, my empirical formula is C3H5Cl. Now, we don't need to worry about the order of the atoms. You can use the order that it's given in the problem, and that's fine. We're just looking for the correct ratio of those atoms. Now, once I get my empirical formula, I must find the empirical mass. And I have 3 carbons, which is 3 times 12, and I have 5 hydrogens, which is 5 times 1, and 1 chlorine. And remember, because oftentimes mistakes are made at this point, I'm going to rewrite and multiply these numbers out. And when I add them together, I get 76.5 AMU is my empirical mass. And then I take the empirical mass and divide it into the molecular mass, and it goes twice. And that will always be a whole number. If it's not a whole number, you might want to recheck your numbers. Therefore, I'm going to multiply my empirical formula through by 2, and I get C6H10Cl2. I do not put a 2 in the front because that would say that that formula, that molecule, has 3 carbons, and it doesn't. In nature, it occurs with 6 carbons. Therefore, you must multiply the subscripts through by 2. Is what we got is a relationship between the simplest ratio and the ratio in the molecule. And I multiply that through, and that gives me my molecular formula. And that's how you do number 1. In number 2, we are determining the percent of sulfur in the compound. And you can see why it's very important that you determined how to write formulas from names, because we are using it all the time. So we're practicing and practicing. Now, sulfuric acid is H2SO4. And I need to get the formula mass. There are 2 hydrogens, which would be 2 times 1. Sulfur is 32.1, and 4 oxygens is 4 times 16.0. And I write it again after I've multiplied so that I don't make any mistakes. And I get 98.1 AMU. Therefore, I take the mass of the sulfur divided by the total mass times 100, and I get 32.7217, and we always express percents to the tens place. Therefore, my answer is 32.7% sulfur. Now, in the second one, hydrosulfuric means there's no oxygen in this compound when you have hydroic. I have 2 hydrogens, which is 2 times 1.0, and sulfur is 32.1. I write it again, and therefore I get 34.1 AMU is the total gram formula mass. And I take my 32.1 divided by my total times 100, and I get 94.1348, and therefore it's 94.1% sulfur in that compound. Now the next one, again, I needed to remember that the Roman numeral is a charge on the first element. And therefore, my formula is SO3, because compounds must be 0. Sulfur is 32.1. 3 oxygens is 3 times 16.0. Therefore, I have 32.1 plus 48.0. And that gives me 80.1 AMU for the formula for the mass of this formula. Then I take my 32.1 divided by my 80.1 times 100 to get the percentage of sulfur, and I get 40.0749, which gives me 40.1% sulfur in sulfur 6 oxide. Now for this last one, I have 2 sodiums, 2 times 23.0, sulfur is 32.1, and 4 oxygens is 4 times 16.0. Therefore, I have 46.0, 32.1, and 64.0, and when I add them together, I get 142.1 AMU. I take my amount of sulfur and I divide it by my total times 100, and I get 22.5897, and therefore 22.6% sulfur in that compound. Now, it was kind of interesting here that the sulfur was always just 1 sulfur in these compounds. That doesn't always happen. Sometimes you may have a greater number in that compound, and therefore you would need to multiply however many you have in your numerator. And that's how you do number 2. You have a review worksheet to work on for the rest of the period that you will devote to this lesson. And you also have a lab on hydrates that is due tomorrow. And we've had several warm-ups that tell you or help you, guide you through what we're trying to find. The only thing that I would like to discuss with you is that in order to determine the experimental percentage of water, you would take the mass of the water divided by the original mass of the hydrate times 100. That would give you the experimental mass of water in the hydrate. Also, one of the questions asks why we have to weigh it immediately and not wait until later. Well, some areas of this country are very, very humid and that moisture could get back into the hydrate. We try to limit that. And also, we cannot weigh it when it's warm because hot air rises, and that would make my mass lighter because of the buoyancy there. And also, it's not good for our scale, so we measure it immediately as soon as it cools completely. And I hope that that helps you. And the only other thing I could think of is maybe in the further investigations, that first question is actually two problems. You will get calcium nitrate with different amounts of water in the crystals. And therefore, I think that that's all you need to know today. Well, you do the best you can on that review worksheet. It's a very good guide for what you can expect on the assessment in a couple of days. Well, that was some fun, and thank you for being here, and I can't wait to see you tomorrow.